Okay, we're going to finish out section 5.4 and 5.5 by graphing the reciprocal functions of sine, cosine, and tangent, which are cosecant, secant, and cotangent. So the first thing is you've noticed I've already drawn out my axis right here. My degrees on the x-axis, my quadrantal angles, 90, 180, 270, 360, and my y-axis labeled as 1s and 2s, negative 1s and negative 2s. So if you haven't done that already on these last 3 graphs, you might want to pause this video and do that because I'm not going to do it within my work. All right, first thing, just like before we did, was we took our table and we're evaluating at each of these functions that we have left. So let's look at cosecant first, and we're going to look to find the cosecant of 0. So using my chart, cosecant of 0 is undefined, which we saw that before in tangent, which tells me we have an asymptote there. So cosecant of 0 does not exist, or you can write UND there, doesn't matter. And then we've got 90. The cosecant of 90 is 1. The cosecant of 180 is undefined again, so that does not exist. And the cosecant of 270 right here is sitting at negative 1. And the cosecant of 360 down here at the bottom is once again does not exist. All right, we're going to use coterminal angles to get back to the other side. So negative 90 was the same thing as 270, so that's negative 1. Negative 180 is the same thing as positive 180, so that does not exist. Negative 270 is the same thing as positive 90, so that's positive 1. And negative 360 is the same thing as positive 360, or 0, which for all does not exist. All right, let's draw these does not exist out first, because this is going to be my vertical asymptote. So first vertical asymptote I got is at 0, so that is basically my y-axis. We're going to kind of shade that to the right a little bit there. Next one I got is sitting at 180. The next one I got is sitting at 360. All right, going back the other way, I got one at negative 180, and I've got one at negative 360. So these are my asymptotes. All right, let's graph what we're left with now. At 90, I'm going to go up to 1. So here's 90 degrees, go up to 1, put a dot. At 270, I'm going to go down to negative 1. So 270, negative 1, put a dot there. All right, going back the other way. Negative 90 is at negative 1. And negative 270 is back up to positive 1. Now, all we see are these up and down things, but we've got to go and look at other things in order to get our solution out for us. So let's try to evaluate this at 30 degrees right here. So I'm going to try to find the secant of 30 degrees. So using my chart, I'm not secant, cosecant. The cosecant of 30 degrees is 2. So at 30 degrees, I'm going to go up to 2 and just put a little bitty dot right there. All right, now I want 60 degrees. So the cosecant of 60 degrees is 2 on the square root of 3 over 3. So I'm going to use my calculator to evaluate that there. So I've got 2 on the square root of 3. That gets divided by 3, and that gives me out about 1.2. So if this is 60, I'm going to go up 1 and just a little bitty bit more. All right, so as you can see, this is like a half a parabola looking like this. All right, let's come over here. Now remember, these are all 30 degrees. So this is 30, 60, 90. So now we've got 90 plus 30. So this right here is 120 degrees. So the next thing I'm going to find is the cosecant of 120. Look at there. It's the same thing. 2 on the square root of 3 over 3, which was that 1.2. So at 120, it's about 1.2. All right, next thing I'm going to do, if this is 120, I'm going to add 30 more degrees, and that's going to be 150. So the cosecant of 150 is 2 again, which matches over here. Now, as you can see, this shape right here is going to make a parabola. So this is a parabola that opens up. Now get close to those asymptotes, but don't cross them and don't touch them. All right, now let's look at something over here with the negative angle. So we have negative 90 being negative 1. Now this is negative 30. Negative 30. Now we don't like negative 30, so we're going to add 360 and get out 330. So I'm going to find the cosecant of 330, which is negative 2. So negative 30 is down here at negative 2. If this is negative 30, then this is negative 60. If I take negative 60 and add 360, I get out 300. So the cosecant of 300 is negative 2 on the square root of 3 over 3. So that's that negative 1.2. So negative 60, negative 1, and just a little bit more. Now you can probably figure out what's going to happen right here. All right, so here's negative 90. Negative 90 plus negative 30 is negative 120. Well, I don't like negative 120, so I'm going to take negative 120 and add 360, and that's the same thing as 240. So the cosecant of 240 is negative 2 on the square root of 3 over 3. That's that same negative 1.2. so negative 1.2. Now you can probably see what's happening here. All right. The next thing I'm going to take is negative 120. I'm going to subtract another 30. There's that negative 150. We don't like negative 150, so I'm going to add 360. That gives me 210. So the cosecant of 210 is negative 2. So negative 2, which is down here. All right, hopefully you can see that this right here is a parabola that opens down. So let's use symmetry to get us there. Now this right here is sitting down here at negative 1, so it should look very similar to this. So this is a parabola that opens down. This right here is sitting up at positive 1, so this right here should be a parabola that opens up. Now when we go to graph secant, we're going to use the properties of cosecant to help us out right there. All right, so that's what the graph of cosecant looks like. All right, now let's take it and look at the graph of secant. So if I'm going to graph secant, a different color here. If I'm graphing secant, I'm still going to start at the 0 right here, and I'm going to use my chart to get to my solution. So here's secant. The secant of 0 is actually 1. The secant of 90 is undefined, so that does not exist. The secant of 180 is negative 1. The secant of 270 is undefined, so that does not exist. And the secant of 360 all the way down here at the bottom is positive 1. All right, negative 90, same thing as 270, so that does not exist. Negative 180, same thing as positive 180, so that's negative 1. Negative 270, same thing as positive 90, which does not exist. And negative 360, the same thing as 0, which is back to 1. So anytime we see these D and E's, we got vertical asymptotes going on once again. All right, so let's start at negative 270, vertical asymptote at negative 270. Then our next one is sitting at negative 90. Then we've got one at positive 90. And then we got another one at positive 270. All right, now let's graph our numbers. At negative 360, we got out positive 1. At negative 180, we got out negative 1. At negative 90, I'm sorry, at 0, we got out 1. At 180, we got out negative 1. And at 360, we're back to positive 1. Now, using the same symmetry that we got going on similar to this right here, we can notice that anytime we have a high point at 1, it's going to be a parabola that opens up. Anytime we have a low point down here at negative 1, it's going to be a parabola that opens down. So this right here is a half a parabola that opens up. Here we have a whole parabola opening up because this is a high point. And right here, we have another parabola or half of one that opens up. Now, these are negative ones. So these right here are going to be parabolas that open down. Now get these parabolas close to your asymptotes, but don't cross them and don't touch them. So that's cosecant and secant. Now, what you will notice about cosecant is secant. If I go back to cosecant right here and draw this graph, if you can see this in yellow right here, this is actually the sine graph. So this right here is just the reciprocal of sine, and I can go back this way right here. All right, same thing right here for cosecant. Paper moved. If I go back and draw this graph, this is the graph of cosine. So it kind of follows the path of its reciprocal function. All right, last one we have to look at to graph is our cotangent graph. All right, this is all for Dylan right here with his Clemson right here. So here's Marge. All right, so we're going with cotangent right here. Cotangent of 0 actually happens to be undefined, so that does not exist. Cotangent of 90 right here happens to be 0. Cotangent of 180 right here happens to be undefined, so that does not exist. Cotangent of 270 right here, which is back to 0. And then cotangent of 360 down here at the bottom does not exist. All right, coterminal angles to get me into my other directions right here. Negative 90 is 270, so that's 0. Negative 180 is positive 180, so that does not exist. Negative 270 is the same thing as 90, so that's 0. And negative 360 is the same thing as 0, which does not exist. All right, D and E's once again means I have asymptotes. So let's draw all of my asymptotes out first. So I got one at negative 360. I got one at negative 180. Going with my chart right here. Next one is at 0. Next one is at 180. And the last one's over here at the end, which is positive 360. All right, next thing I'm doing is graphing all these zeros. So at negative 270, I need a 0. At negative 90, I need a 0. At positive 90, I need a 0. and at 270 I need a 0. Now, similar stuff we did to tangent, we got to figure out what this graph looks like. It's going to be similar to tangent up here we graphed already. All right, so let's take it and look at between 0 and 180. So here's 90. So this is 30, 60, 90. So let's look at the cotangent of 30 first. So here we go. The cotangent of 30 is the square root of 3. And remember, we've already done the square root of 3, but let's look at it again just so we make sure we know what we're talking about. The square root of 3 is 1.7. So at 30, I'm going to go up to 1. Remember, there's 0.5, so 0.7 is about right there. All right, next we're going to look at is 60 degrees. The cotangent of 60 degrees is the square root of 3 over 3. So let's look at that. The square root of 3 divided by 3 was that 0.6. So at 60 degrees, it's going to be about 0.6. Remember, this is 0.5, so just a little bit up there. So this is a half a parabola that opens up, if you can see that. All right, so this is 30, 60, 90. 90 plus 30 is going to give me 120. So we're going to look at the cotangent of 120 next. The cotangent of 120 is negative square root of 3 over 3. Square root of 3 over 3 was 0.6, so this is just going to be negative 0.6. So at 120, here's negative 0.5, so negative 0.6, just barely right there. All right, next we're looking at is 150 degrees because 120 plus 30 gives me 150. So the cotangent of 150 is negative square root of 3. Remember, the square root of 3 was 1.7, so this is just negative 1.7. So we're right here at 150. So we got negative 1.7. There's negative 1, negative 1.5, negative 1.7 looks similar to that. So when I draw this graph, there's my parabola that opens up, and here's my parabola that opens down. So it's basically the same thing as this function right here, just flipped upside down. So if this is x cubed, this would actually be negative x cubed. All right, so there's one rotation. So we're going with our another rotation. And we're going to graph these other rotations right here on the left-hand side of this graph as well. So this right here is the graph of cotangent x, similar to tangent, where it's just shifted and it's flipped upside down. All right, next thing we're going to do is take those graphs that we just graphed, and we're going to go back and look at the domain, range, zeros, asymptotes, and so forth. All right, so let's go back and let's look at cosecant first. Let's start there. All right, now what I've done is I folded this chart down just so we can put it right up under there and see what we're talking about. All right, so let's go with cosecant first. When we do cosecant domain, we want everything but the asymptotes. So basically, this is everything but these asymptotes sitting right here, okay? So we've got all our numbers, but x cannot equal, and let's start listing those asymptotes out. Look what we got, plus or minus 360 and plus or minus 180, and don't forget 0 right there. So I'm going to start off with that 0, and then plus or minus 180, and then plus or minus 360. All right, next thing is my range. Now look at my range. It's going up and it's going down, but I do not have a graph between negative 1 and positive 1. So basically, I've got everything from negative 1 and down, or less than, and positive 1 and up, or greater than. So to write that, we're going to say y is less than or equal to negative 1, because it can equal it because we got closed dots there, or because we got a gap, y is greater than or equal to positive 1. All right, next thing we're doing is we're listing our zeros. Well, if you notice here, this never crosses the x-axis. It's all above, 1 or above, or it's all below negative 1 or below. So we have no zeros for cosecant. Next thing we're going to do is we're going to list our asymptotes. We've already listed them, 0, plus or minus 90, and plus or minus 360. So x equals 0, plus or minus 90, and plus or minus 360. All right, next thing we're going to talk about, I'm going to scoot this over, is the period, and if this thing's even, odd, or neither. All right, the period for this function, very similar to sine. We need a parabola that opens up and a parabola that opens down. So from here to here is one rotation for this cosecant function. So that's from 0 to 360. So the period for cosecant is 360 degrees. Now, even, odd, or neither. Even function has to be symmetric with the x-axis. The right-hand side does not match the left-hand side, so it's not even. Is it odd? It sure is, because if I take this and scoot it around, it is going to come out to be the other one. Remember, we said cosecant was an odd function. The only two even functions we had were cosine and secant. Everything else was odd. So there's cosecant. All right, next one, I'm going to scoot this up, and let's look at our secant graph. All right, so here's my secant graph. We're going to fill this out right here that goes with secant. All right, secant domain is everything but my asymptotes. So my asymptotes are sitting at plus or minus 270 and plus or minus 90. So we're going to say everything, all our numbers, but x cannot equal plus or minus 90 and plus or minus 270. All right, look at the range. It's very similar to cosecant. 1 going up, -1 going down. We got a gap in between here. So it's exactly the same thing. Y is less than or equal to -1, or y is greater than or equal to +1. All right, asymptotes. This green graph, which is secant, never crosses this x-axis. The cosine function does, but the secant function does not. So it has no zeros. All right, next thing we're doing is we're listing our asymptotes. We've already done those before. Plus or minus 270, plus or minus 90. So we're just going to rewrite that back over here. All right, next thing, the period for this function, it should match cosine. Remember, cosine was 360, so let's see how it matches right here. Here's a parabola that opens up, and here's a parabola that opens down. So it's the total distance between -90 and 270. We can't just say 270 because we got 270 plus another 90 right here. So 270 plus 90 gives me 360. All right, even, odd, or neither. If I put my pin right here across the y-axis, as you can see, it matches up. The right side matches the left-hand side, so this right here makes this an even function. All right, my last graph that we have is cotangent right here. So we'll scoot this all the way back over, and let's look at cotangent. Cotangent, my domain is everything but my asymptotes. My asymptotes are plus or minus 360, plus or minus 180, and 0. So I'm going to list those out. So all real numbers, everything, but x cannot equal 0, plus or minus 180, and then plus or minus 360. All right, range. As you notice, it matches the range for tangent. Everything's up, everything's down. So this right here is all real numbers. You could also say negative infinity, positive infinity if you're doing this in interval notation. All right, next thing we're doing is we're listing our zeros. Zeros at where it crosses the x-axis. It crosses at plus or minus 270 and plus or minus 90. So I can just write just like that. X equals plus or minus 90 and plus or minus 270. All right, next thing's asymptotes. We've already listed those. 0, plus or minus 180, plus or minus 360. So I'm just going to write them as x equals now, because vertical asymptotes, a vertical line is written with x equals coming in front of it. All right, scooting it over. Next thing we're going to do is look at the period for this function. Well, here's one rotation from here to here. So that's from 0 to 180 degrees. So it matches tangent. 180 degrees is the period for tangent and cotangent. Now, even, odd, or neither. It's not an even function because this side over here does not match this side. Now it matches, but it's got to flip to match it. If this thing were to flip, it would actually be sitting upside down looking like this. So this is not an even function, but it is an odd function because it can rotate around to get to my point. So remember we said there's only 2 even functions, cosine and secant. Everything else is odd. So that takes care of all of our graphs for all 6 trig functions.